In this video, we're looking at how we might use the chi-squared test. So we've got a table that shows the responses of a randomly chosen sample of adults regarding the person's weight and whether they have diabetes. We've got a 5% significance level. Remember, that will be given to you, and a critical value of 5.99. Now, how do we know that? We could look at our table and say, all right, well, it's a 2 by 3. If I take out the last row, how many degrees of freedom? 1, 2, and we've got a 5% significance level. We can check our table. So we've got 2 degrees of freedom, we've got 5%, we've got 5.99, which was what was given to us. Test at a 5% level whether there is a link between weight and the suffering diabetes. So what we're going to do is pop it into our calculator. Now remember, we go to our main screen, so just our normal screen, we click on Matrix, Matrix A, and we head into there. Now I've filled ours out already, so 11, 19, 26 corresponding. I'm going to jump out of that and head to Statistics. I'm going to click on Test, Chi. Which matrix? Well, it's Matrix A. Okay, I'm going to scroll down and execute. Now I've got an x-squared value of 6.61 and a p-value 0.04, we'll say. Alright, now our H0, so the null hypothesis, our statement would be so that they are independent. So we would say that there is no relationship between weight and diabetes. That would be our null hypothesis. Our alternate hypothesis would be that there is a relationship between diabetes and weight. And we probably know what the answer is going to be. Alright, so we've got our values. So the rejection inequality, our x-squared value of 6.61 greater than k. So is it greater than our k value? Well, our k value was 5.99, so it is greater, so we reject it when it's greater. So we would reject our null hypothesis. We'd also use our p-value as a second piece of data to confirm this. So our p-value was 0.04. We had a 5% significance level, so our p-value, p is less than 0.05, so again, we reject our null hypothesis. So two pieces of data telling us the same thing. So remember, you need your x-squared value and your p-value. You reject it if x-squared is greater than the critical value, and you reject it if your p-value is less than your significance level. One more example. So our example here, we're going to come back into Matrix. So I'm still in the chi test. So it's a 2 by 3. Oh, sorry, it's 2 by 4. I'm going to add in an extra column. Okay, so exit out of that. Now I've got 7. Alright, so, oops. Test, scroll down, I've got my data in there, execute. Okay, so there's my data. Let's have a look at the question. Survey was given randomly chosen high school students from years 9 to 12. Change to the canteen. The contingency table tells the results. 5% significance level. So test whether the student's preference depends on their year group. So our null hypothesis, saying that they are independent, we would say that the student's canteen preference does not depend on the year group. Our alternate hypothesis would be that the student's preferences depend on their year group. Now, we've got a 5% significance level. We are not given the critical value, so we need to work out our degrees of freedom. So to do that, I'm just going to cross out the last row, cross out the last column. 3 degrees of freedom. So df equals 3. I'm going to come over 3 degrees, 5%. My value is going to be 7.81. Now, my x-squared value was 5.81. My k value is 7.81. Is x squared greater than k? Well, no, it's not. So we're not going to reject it. We would accept it. Our p-value was 0.121. We're working at a 5%, so this stays at 5%. Is p less than that 5%? Well, at the moment we're at 12%, so we would be looking at this one here, so that 0.05, we do not reject it. So both pieces of data are saying that we would accept our null hypothesis, that students' canteen preference is independent of their year level. So that's how you use your data, the tables. You'll normally be given your critical value, but that is how you would calculate your solutions.